那我们以热烈的掌声欢迎小林茂先生开始演讲。
I'm Xiao, and Associate Professor of EMS. So I give you a talk these topics. So I'm working at EMS. So it's and for Japan, so the Far East country in Asia. So EMS is located in Ogasu. So Ribu is here. So it's a center of Japan. So about 40 kilometers from Tokyo. So there are various manufacturing industries such as automobile, airplane, communication machines, in addition to traditional power industries. So EMS is one of the first schools in Japan established in 1996 to explore progressive media arts and science fields. So EMS was graduate school in Japan. So 19 faculty members and roughly 50 students can design art, engineering, and social work. So it's small. So the name is quite long, so that's why we just call EMS. So basically not EMS. So though we are very small, so we have very strong networks with graduates who are working at cutting-edge areas like this. So at this moment, the most famous graduate is Daigo Manabe. So roughly 50% of his team, Lysomatics, EMS graduate. So a project by Lysomatics and collaborators gained a grand prize at Japan Media Festival this year. So really popular. So the team have been collaborating with both stage and the website. So at this moment, they provide motion capture data or packet and some data, so to create new pieces from the data. So that's really challenging. So they are so progressive. So and this is as a project directed by a graduate team lab. So one of the most progressive art and technology team in Japan. So it's a large-scale digital signage at Tokyo Sky Tree. So the highest tower in Japan, over 600 meters. So and this is a piece by a graduate and his collaborator. Please watch the video after this. So as you see, it's a very simple system. So but the results are interesting. So it's a sensory storing board. So a project by graduate and his collaborator. So and one more thing. So Yota Kawakubo, so an artist and also EMS graduate, will join as an associate professor. So we are very small, but expanding through network through these graduates. So and we are basically an multidisciplinary institute consisting of design, art, and interface for the social context. So teachers and students have each background and skills, and who relate programs in society with utilizing skills and regards to local and global collaborators. So since I'm basically the design devices are beyond conventional computers and smartphones and tablets. So, and next is interaction. So we have been exploring possibilities of interaction with utilizing new interfaces. So and next is prototyping. So it's so as you might already experience build to think. It's quite important to have ideas. So we strongly recommend students making prototypes and discuss and think utilizing prototypes to develop ideas. So the final keyword is publications. Like this school, so we have digital publication tools such as laser cutters, 3D printers, and so on. So we also have a civic workshop with digital publication tools to facilitate open innovations. So now we have various areas of design. So through these activities, we are trying to do a big picture of design. So instead of segmented and specialized design. So I talk about case studies at our school right now. So let me introduce about myself briefly. So before joining EMS, I worked for Roland, Vision News Management Company. So I started my career in 1993 as a sound designer. So I designed sounds for digital pianos, synthesizers, and professional use equipment such as karaoke. So several years later, so I moved to the R&D department since I was interested in progressive technologies. At the time, I was a tech guy, so and I contributed to transform fundamental technologies at the research lab to real products. So I created various prototypes, demonstrated uncountable times. So after that, I moved to the new department to join the new development team of video editing system. I worked as a software engineer from bottom to top, audio signal processing to green. So there are very important experiences for me to teach interaction design and prototyping at EMS. So after releasing these products, I felt I need change. So I left Roland and joined EMS in 2004. So after joining EMS, so many students asked me to please teach me how to make new interfaces or make new interactions or make new installations. So but at that time, so it was not so easy to connect computer to sensors and actuators. So that's why I developed a toolkit called Data in 2005 with students and teachers to fill gaps between the physical and the virtual. So, and I released the toolkit as open source hardware in 2006. So, and recently, so I worked with smartphone electronics in the United States to develop an Arduino. So it's Arduino field. So it's capable with a wireless connection. So it was in 2010 maybe. So and I also have been writing articles to make magazine in Japanese. So and I also wrote several books. So this is for now. So I'm really happy to see the book is also available in Taiwan. So and this is a book to introduce various ways of prototyping with utilizing Arduino. So how many have seen the book? Okay, thank you very much. So let me introduce this one. So this is an example from the introduction part. So this is jamming here. Digital musical instrument. So actually, it's a prototype. That might look like our product. So we have been utilizing digital application tools like you to realize ideas through sketching in hardware. So let me introduce jamming here. So jamming here consisting of the physical interface part and the sound generating part. The idea is very simple. It's a musical instrument plays with gears. The center gear has the power, so the other gears sound like this and play sound. And you can change tempo, so and direction by using like the gears like this. So you can play music like a DJ. So you can combine multiple gears if you want. So let me show another example of jamming gear. So in this case, use two straight gears. So left gear has 96 feet, so and right one has 95 feet, so a bit different. So the phrase is very simple, just 8 notes. So but combining these two. This is a piece by a very famous contemporary musician, composer Stephen Reich. So it's a piano piece. So originally composed for piano and cake. So but he rearranged it to be played with jamming gear. So and this is a process of making jamming gear. So I hope that readers will understand what and how the project by reading finished prototype and the processes. So in the book, I also introduced various projects in collaboration with interesting creators. So, and let me introduce 3 or 4 research projects at our institute. So first one is action in puppet by Tomomi. So you might be familiar with the sound. Actually, it's a bit stupid, but it's a electric toy. So finger puppet plays sound by playing on the table, desk, on the floor, or something. So there are sensors, so we can play in various ways. So she implemented various interactions. Okay, so when Tomomi started the project, she was a first year student of the graduate school. So she had little programming skills, but no electronic skills nor 3D CAD skills at the time. So she realized in roughly 6 months, including the period to acquire skills. So firstly, started with research on various toys and ways to play. So and then draw these sketches of her ideas. So we have been preparing a format to draw idea sketches. So by drawing in a format, so participants to an idea sketching session can share and develop ideas. So in addition, so participants who believe not good at drawing, for instance, I'm engineering guy, so I'm not good at drawing pictures. can start drawing just after an introduction. So and this is a format we have been using. So we use 4 types of pens. So and we prepare special paper, actually just very cheap paper. So to draw in a format. So by drawing in a format, it's easy to share, sort, building on ideas of others, or combining, dividing, or picking out, or mix together. So it's quite easy to share and develop. So that's why we have been utilizing the format. So and taking a few ideas, so start making a dirty model like this. It's a very quick model with clay. So and then so make a sketching with a video. So at this point it's a fake. So it's just a model built with phone core. So but she edit take a movie so and add sound after that to what kind of sound is good for the product. So or how the experience will be so fun or not so fun. So without this process, it's easy to spend so long time to evaluate ideas. So making prototypes 6 months after that, this is not important or this is not so fun. So it's just a waste of time. So to avoid such kind of situation, so we strongly recommend to sketch in the beginning. So and this is another sketching method, hardware sketching. So usually, so it's easy to sketch on paper or sketch with software. So but sketching in hardware is not so easy. So that's why we utilizing various toolkits. So and teach students how to interact with sensors, actuators. So how to very simple program to evaluate your ideas. So this is very important point. So the students will make a hardware sketching several hours and try. So okay, not good. Okay, try next idea. So that's how. So they can try several or 10, 20 hardware ideas in a week or something, ideally. So and after that, from make a prototype. In this case, she utilized a 3D printer and a CNC machine to fabricate printed circuit board. So and implemented with better software implementation. So at last, so the sketch is now a prototype like this and can play by children. So and exhibit in the space. So okay, so let me introduce the next one. Next one is Esther Domino. So basically it's a domino. So but usually domino pies turn down. So with touching. So but it's wireless. So turn knock off in order of each ID. So you can identify ID. So like that, nice. So you can change ID by shaking. Like this. So since it's physical, so that depends on the physical positions and physical environment. So you can play with a real domino pie. So the blue one are official domino pie. So and when so reaches to the end, we'll back to the phone, so you can play forever. Okay, so it's a domino. Thank you for joining. So, actually, the first idea sketch was like this. So, and I clearly remember. So how can I say? So I support the students. So this will be stupid. So don't do that. So, but the students really want to make that real. So that's why he realized in just 2 months. So the first one is like this. So the cabinet is just printed out from a 3D printer, so because it's just a few days before the exhibition. So, and the inside was like this. He utilized various existing hardware to realize that idea. The core component is artificial muscle actuator, so actually meager nanomuscle. So, and he combined with wireless modem XB to realize that idea. At that time, it was complicated because it required a PC to control all domino pies, and battery of each pie just lasts only 1 or 2 hours. So that's why the students have to be in the backyard and charge and change, charge and change, charge and change for days. So, but he didn't give up. So he developed 4 to 5 prototypes. So in the first prototype, the pie can last over 10 hours per day. So and can be played with 20,000 people in a big exhibition in Japan. So and through the process, he utilized open source hardware. So this is a circuit board, the fourth domino, SY domino. So he derived the design from mine. So it's Arduino field. So from physically, so these two are totally different, but digitally, these two are mostly equivalent. So he utilized my digital design data, so and removed and used unneeded components, so and rearranged and add new components like artificial muscle, so and redesigned the board like that. So and actually, I derived Arduino field from Limitant Arduino, so it was it's an Arduino so to be utilized for wearable project. So these three are digitally mostly the same, but physically totally different. But it's a fun part of open source hardware. So by utilizing the open source hardware, we can save time. So and realize looks like real prototypes. So okay, go to the next project. It's UV camera.
情報科学芸術大学院大学のグループはファインダーの代わりに指で構図を決めて撮影できる指カメラを開発し
Usually our people take a gesture like this when you meet beautiful scenery or beautiful lady, I don't know. But, so it's a natural gesture to make a frame. So and he realized the idea to take a picture by make a gesture like this. So you might be familiar with the Sixth Sense project by MIT Media Lab. So it was a great project and much richer context. So regarding the make a frame and take a picture, so the students realized the idea in very simple technique. So since that was a catchy idea, so was featured in Diginfo and Gadget Core 727, so and 4 or 5 TV programs in Japan. So but the first idea was like that. So very simple. So I believe that over 1 million people all around the world have this idea. So it's very simple and common idea. But how to realize was not so easy. So that's why there are no many implementation of that idea. So firstly, the student So actually, it's a collaboration of two students. So okay, I don't know, but maybe like this. So it's a stupid sketch using the ductile tape on phone call. So maybe like this, and please look at the tips of fingers. So there are tape. So that means we might need a sensor there. So next week he draw sketching in hardware like that. So and add a web camera. So and he confirmed that okay, so I can take a picture. So and maybe distance proximity sensor will okay to measure distance from the camera to the face. So but the problem was sensor to two fingers. So because this is not realistic. Because if you want to take a picture, so okay. Take picture. This is not real. So that's why he tried to find the solution. So first solution was globe. If the camera was mounted on the globe, so it's easy to take. But not real. So but through hardware sketching, finally he found that the sensors don't have to be on fingertips. So that can be inside of the camera body. So that's why the final prototype is much simplified. So just take off from the pocket and put on the finger. So and take photos. So and then his team realized to design the static floor. So and design the enclosure. Like that paint and put every component inside. So and make that project like that. So this is our UV camera. So and I'll introduce another totally different project. So this is another example of student project. So he has skills in product design. So and he met an artisan of self-helping tools. So the artisan, Mr. Genju Kato, lost his fingers by an accident. So he wanted self-helping tools for himself. He got ideas and asked professionals, but they rejected making on the grounds that his ideas are not common sense or will be expensive. So that's why Mr. Kato started making self-helping tools by himself. So since he is an artisan, so he don't draw blueprints. So that's why it's difficult to understand his design concept from outside. So to understand his design concept, the students analyze self-helping tools made by Mr. Kato. So then we design to be fabricated with digital fabrication tools, in this case, a laser cutter. So that's how the student understand Mr. Kato's design concept. So in similar way, he designed self-helping tools in collaboration with our welfare team consisting of volunteers who have professional skills and published at the Thingiverse. So Thingiverse is a platform to share digital design data and projects. So this is a nail clipper for one hand. So he redesigned Mr. Kato's nail clipper for digital publication tools and published and featured at Thingiverse. So then he designed a nail clipper for half-paralyzed person. So since the person wants to utilize both hands for rehabilitation, so the student arranged the nail clipper with this. So and he has been utilizing the nail clipper in daily life. So and then published at Thingiverse to let others duplicate and make variations. So this is very important. So the team also designed various self-helping tools such as a pet bottle cap opener. So these tools are useful for not only what is called handicapped people, but also elderly people. So since the digital part made diversity, complexity, and flexibility to be. So people can make a suitable size, color, shape in preferred material. So though this is a small step, but utilizing digital fab tools will be the next big thing in welfare. So I got this idea through the project. So, and next one is also totally different. So it's a company called Nakadai. So Nakadai is an intermediate industrial waste processor. So they achieve over 95% recycle rate. So, but they were not satisfied in this. So since industrial waste is different from garbage, so when a product is discontinued, what was called product becomes industrial waste immediately. So and then they collect material, collect industrial waste, and then repurpose as a material to make new. So guess what's this? You should be familiar. So anyone have an idea? So it's inside of Ethernet cable. So there are various plastic material inside the cable. It's very long. So and they repurposed to making new fabric or making new something. So it's inspiring material. So and there are various materials like this is our optical discs. So and it's a copper components like that. So and they held the second industrial waste summit in last year. So the theme provided by Nakadai was a design that doesn't use made with waste as an excuse. So what's a good challenge for us? So actually, this is the first sketch of a stylus consisting of a glass tube from a stationery company. Actually, it's a very famous stationery company in Japan. So and copper wires from a manufacturer, actually Sony. So and conductive fabric. So I made this in 5 minutes, but this is not a product, but a sketch. So how might we transform jumbo or industrial waste into a product with keeping stories of materials? That was challenging. So to tackle this, so we utilize digital power tools, in this case laser cutter, to fabricate custom components that glue materials together. So this being our first step to developing innovative method and putting a new face on manufacturing. So the small sort of pen tip is made using a conductive fabric encasing ball of copper wire. So this is held in place with interlocking components and a handy clip made from a laser cut fabric. So and this is the final one. So looks like a product, I hope. So I'd like to conclude the student project, research project ideas. So lessons learned from the project are prototyping. So being to think is a key to develop ideas. So and actually, so digital fab is the key to go beyond the conventional ecosystem. So that means mass production and mass consumption. So next week, so next 15 minutes, so I will talk about the maker movement in Japan. So basically, the book by Chris Anderson is really hot in Japan. So was published in October in Japanese and in English. So and the publisher tried to sell much of books. So that's why much copies. So that's why they strongly recommend to read the books. And there is a boom, the stupid boom of 3D printers in Japan. So but actually the maker movement was coined by Dave Daugherty. So he is co-founder of O'Reilly Media, so and founder of Make. So let's look at a few just 1 minute for the video take off.
This ability to make things, to grasp things with our hands. We use words like grasp metaphorically to also think about understanding things. We don't just live, but we make and create things. Well, I'm going to show you a group of makers from Maker Fair in various places. It doesn't come out particularly well, but that's a particularly tall bicycle. It's a scraper bike, it's called, and it's from Oakland. And this is a particularly small scooter for the gentleman of this size, but he's trying to power it or motorize it with a drill, right? The question we have is, can I do it? Can it be done? Apparently it can. So makers are enthusiasts, they are amateurs, they're people who love doing what they do. They don't always even know why they're doing it. We have begun organizing makers at our Maker Fair. There was one held in Detroit here last summer, and we held again next summer at the Henry Ford. But we hold it in San Francisco. Yeah.
So the talk will last many minutes, so maybe you can watch it later on. But the very important part is the real creatures who need to make. So actually, it's the voice by Frank Villa, so it's music like that. So it's quite important. So and last year, so we held mini maker fair in our local city.
この夏、岐阜県大垣市でユニークな展示会が開かれました。機械工作や電子工作、アート作品や手芸、そして実際に販売する製品まで手作りの幅広い作品が並んでいます。
So we held our mini maker fair in our town. So our town, Ogaki, is a small local city in Japan. So there are roughly 160,000 people. So though the city is small, but we welcome over 140 teams of makers and over 5,000 visitors from various areas of Japan. So and there are so many interesting projects from smart home accessories, so Geiger counter, so and many toys, so and installations and electronic something, musical instrument. So there are so many projects and in addition to craft projects here. So there are the pictures of the mini maker fair. So we are really excited to welcome 5,000 visitors. So and there were various types of makers from small to large. So and from electronics to craft, so many actually. Handmade laser projector, a musical instrument with touch panel inside. So that looks like a wooden toy, POV display, or high voltage musical instrument. It's actually very high voltage, and it's a projection mapping project to a chair, so quite interesting. So and in a craft project by professionals and amateurs. So I'm really excited. So and I believe that the mini maker fair stimulated people being from consumers to makers. So because usually at a commercial exhibition, so there are many products, but usually just talk about what. So what's this? What's the spec? Might be good. What's the price? When it will be available? So that's a typical conversation at a commercial trade show. But at the maker fair, so the people will talk about why, so and how, and then okay, so I should expect next time. Okay, maybe so your project is really interesting. So and I have that kind of skill. So why don't we collaborate? So there are many conversations at the Maker Fair. So and this is a full version of Maker Fair in Tokyo. So last December. So there are so many projects. So and too crowded to walk and. So at several presentation sessions, there are so many. So and I held a session with 2 other professors to talk about the Maker movement. There are I don't know 200 or 300 people. So and we talked about a lot about the Maker movement. So but please remember. So the Maker movement in Japan was not so. I can say historical thing. So in the first Maker Fair in 2008, April, so there were only 30 exhibitors and 600 visitors in Tokyo. So it was very small. So was held at an international school, very small place. But next one is like this, roughly 2 times bigger. So next one bigger 3 times or 2 times. So and bigger, big. And in roughly 5 years, 4 to 5 years. So maybe start with small is very important. Even if a big city like Tokyo, so we started from very small. So and we are, roughly 130 in comparison to Tokyo, very small city. So but from the first time, we welcomed 4,000 visitors. So because it already there is the Maker movement. So it's very important. So maybe in May, so there will be a Maker Fair in Taipei. Maybe. So I'm very interested in what will happen in Taipei. So and lastly, I want to talk about civic workshop and innovations. So there are various types of workshops, civic workshops. So first one is hackerspace. So it's a membership-based place for people like workshop, tools, and making things. So it's a hackerspace. And the next one is Parkao. So it's an academic-oriented network of workshops coined by MIT. So it's a new action code. So with standardized digital publication tools and openness regarding data, ideas, know-hows, and facility is a key. So in Taiwan in Tech Shop, so it's a membership-based commercial workshop with curriculums to teach people how to use tools. And the fourth one, the latest one, will be Pub Cafe. So in my personal opinion, so as you might know, the Pub Cafe Taipei will open in the beginning of April. I'm really sad I can see the opening of Pub Cafe. But anyway, so Pub Cafe is a cafe equipped with a variety of digital machine tools. So including a laser cutter to provide a space where people can enjoy the thrill of making new things. So it's a Pub Cafe in Tokyo, so in Shibuya. So it's a cafe that there is a laser cutter like these, and there are various products. So and many materials in the cafe is fabricated with laser cutter. So it's different from the laser cutter product. It's a latte, so marshmallow latte. It's a very famous, drink in Pub Cafe. So and the visitors can fabricate these upon existing items like notebooks, smartphone cases, and something. So and so the other visitors can see from inside of the shop. So and when someone starts pub and looks fun, So as a guest join naturally like this. So this is how trader hidden ones. So usually, so the people normally don't touch our laser cutter. So we'll totally disconnected from the daily life usually. So but if occasionally into the cafe, oh, looks like a good cafe. Okay, they take a coffee. Oh, what's that? So it's a beginning of the. So okay, I will make something. So it's a really good stimulation to people. So and now idea is enlarged to 3D printing. So and they are trying to open and enlarge the network. So and I'm really curious to see what will happen in Taipei. So because Taipei is also really good area, so their culture, so and there are many interesting people like you. So I really want to see. So maybe in the next month or something. So and we also have civic workshop in our local town. So it's we call FLAO. So the F stands for various meanings like this. So usually people at big companies fear failures. So but to learn something, so failures are very important. So FLAO is a safe base camp actually. So and FLAO is here. So it looks like big, but actually it's not big. There. So it's a room at the incubation center. So and there are four permanent staff there. So and there are various equipments like these from small laser cutter, paper cutter. So and 3D CNC, so and 3D printers. So and we will change the program from April. So but anyway, so there are various tools. So and visitors can utilize the tools by learning how to. And we also provide workshops to fill gaps. So it's easy to teach how to use a machine. So but what to make is totally different issue. So that's why we utilize design so many workshops to encourage people to start making. So from making buttons, cases, accessories, engraving ornaments. It's a very famous product in Oregon. So making from the human shape. So it's human shaped accessories. So making your a pet bottle cap with your face, with your free of charge applications. So and to fabricate small furniture to the outside one. So and we held a contest. It's a pink eye, it's a blue eye. So I probably with Dragon Ball. Yeah, so it's too old. But anyway, so we fabricate with the outside stools and to ask people to join. So that's in last December. So and we have been holding a series of lectures to encourage people to get ideas about new phenomena, so a new movement. So and this was the last time. So she is a housewife. So started with joining the workshop, but now she operates by herself. So make new things. Okay, so I will make something for my kids. Okay, so I will make something for my friend. So she developed her skills. And the other person made special writing for traditional writing competition in Japan. So and he utilizes the place to make a prototype of his own company, his own small company. So there are various users of FLAO. So and the day after on this Wednesday, so we held a lecture. So and the bottom guy is Mr. Toki. So he is a designer and an artist to make Japanese lacquer product. So looks beautiful, I think. So it's really interesting piece by designers So, but it's totally different from traditional handmade products. So, because he utilized round cells and glass fiber, so to design and fabricate with a laser cutter. So he's trying to combine traditional material and new method. So I really like his genius, and it's really inspiring. So because I know that there are also traditional craft in this area. So but how they can utilize? So how we can combine traditional and new things. So anyway, so we have been working to the area. So and we just finished the first year. So and the community is getting bigger. So I'm really interested in what will happen. So and what we can make. So maybe just one more minute. So there are various manufacturers in this area. So but most of them are just suppliers. So usually suppliers don't know very well about how to make, but don't know about what to make. So they are why to make. So the mission of F-Labo is multiplying local industries and people as makers, not consumers, to generate create innovations. So I try to combine these three. So why, what, and how. So regarding the making things. So to conclude, so there are three lessons learned from the things. So actually, most people are satisfied with working for money and buying, consuming products in 20th century. So, but we are rediscovering the fact that we are creatures who need to make. So in this case, not create from zero to something special as an artist. So for instance, cooking some things, preparing with cardboards, so and building IKEA furniture, so processing at a silk action, these all are made. So, and maybe the change in consciousness might be a chance to create new businesses and reform basic industrial structures. Maybe. Okay, so thank you for listening. So if you want to contact me, so contact me at Facebook, Twitter, and if you are interested in projects at our lab and in institute, so please look at the website. Thank you very much. 谢谢。